Table rock.
Table rock, okay. Flat top, I think, is that's what we're calling it.
Flat top.
So, Ted, why don't you cruise over to flat top? Sometimes you have to go to another perspective so that you can move around. We have imp viewpoint. We have a perspective that allows you to see a polar projection of the terrain. So there's flat top. Okay, so to not use more than my share of the time, we'll go back to the perspective of from the rover. We can incorporate into the model rover images. So going back to the perspective of from the rover, looking back at the lander, Ted's going to load that image in. You see that billboard popped up there? And that's the lander image popped into the terrain model. And now we'll go back to the perspective of looking from the rover's viewpoint. We have a little model, see the little colored model? That's a model of the rover. Let's go down to the rover's viewpoint. And zoom in, and here's the rover now looking back at the lander. So now with this capability, we can start filling in the back sides of rocks and really filling this model out with the rover images as well as the lander camera images. As you can imagine, we're having a lot of fun with this. And plus, it actually is a very useful tool for doing image planning and analysis. All right, I think we'll stop it there. No, actually we can't, because that data, you see those outliers hanging up in space, it's actually only good, the IMP camera disparity is not that great. The eyes aren't that far apart. So any information in stereo is only in the near field, so we're only good out to about 15 meters. And so things on the horizon, you know, the Twin Peaks are a kilometer or more away. You won't get enough information to render those in a stereo model. Can you see that?
We're going to take a quick break. We'll come back and see some more of these fabulous pictures and computer-generated things. What will they give us next? Stay with CNN. Our journey to the Red Planet continues. Bob Reed at the University of Arizona is explaining now to the news conference how the scientists figure out where they're going to go next to study. While he talks about that, we're going to look at the movie made of the rover over the past 24 hours as it made its way over to the rock we've come to know and love as Yogi Bear. We'll watch it a couple of times and listen to Bob Reed.
The soils jump out very nicely here in this representation. You can see that red drifty material is now very bright. It's very red, but this other soil unit is much darker. And this tells us quite a bit about what, we've definitely got two different types of materials on the surface here. Something interesting here, this very bright area here, this is actually the shadow in the previous image of Yogi. Well, why is this so bright? Well, bright means red. Since it's in the shadow, the only light hitting the area in here comes from the sky, and since the sky is red, we see it show up here. So this is actually a measure of the sky brightness. Going over now, we see that these two rocks that were maybe a little more indistinct in the previous image show out significantly brighter here. They're much redder than the surrounding terrain. And finally, we get over here to Scooby-Doo, and this is very, very interesting. Now you notice in the previous image I showed you, it was rather bright, but here it comes out as dark, which means in this representation that it's not as red as other objects in the scene. Well, this is very interesting, because what this means is, this is something we haven't seen on Mars before. We've seen dark things, dark objects like rocks that are not very red, and we've seen bright areas that are very red, like these dust patches. But we've never seen something that's very bright, but also is not very red. So this is a very interesting object. We've never seen anything like this before on Mars. It's the whitest thing we see in the scene. And it's one of our primary targets for further study. And finally, just to show you how we keep learning things as we go in real time, this bright object right here, we discovered this as we were putting these panoramas together for the press conference. First, we thought it might have been a bad pixel or a misregistration, but it's a real object, and it's very red. It's one of the reddest objects we've seen. And if you go back and look on the original image, it's a very dark, deep red object. And this has become another one of our priorities for study. So the rover, we hope, will be heading over in this direction to give us some more information on these sites, and we'll be targeting it with the IMP to get a little more information over here. And finally, if I could have the last slide, just kind of a review. These are the things I've mentioned, and just gives you an idea of kind of what we're looking at. These are just some interesting objects based on color that we see in this particular scene. And again, I like to point out Scooby-Doo is the whitest object we've seen, and I think we'll probably be hearing a lot more about this in the next few days as we get some more information on it. Thanks.
I'd like to take you from the dense rocks of Mars to the tenuous atmosphere of Mars. And to do that, I would like to give you two progress reports from the ASI MET team. First of all, I'd like to put up my first figure, which is the weather forecast and weather report for Mars. And no surprise to you, it is basically the same as it has been for several days now. The atmospheric pressure at 2:55 p.m. local Mars time on Sol 6 is about 6.76 millibars. The high temperature is about +8 degrees Fahrenheit. The low temperature was approximately -100 degrees Fahrenheit. And there was a light wind from the west. The forecast for Sol 7 is pretty much the same thing, so that's no surprise. At this season and time, I imagine future astronauts on Mars would not have much to talk about as far as the weather goes. It would not be a very popular topic of conversation. The second part of my report is actually of a continuing story that we started to present last Monday to you, which is what is the atmospheric temperature profile in the Martian atmosphere. At the day after landing, or the day of landing, excuse me, both Tim Schofield and Rob Manning presented to you deceleration profiles of the deceleration history of the probe as it went through the atmosphere. On Monday, we derived from those deceleration profiles a density profile showing how the atmospheric density on Mars varied from approximately 130 kilometers altitude down to near the surface. What I'd like to present today is the temperatures that we've now derived from that atmospheric density profile. However, before doing that, I'd like to sort of refresh your memories as to a controversy that's existed in the Martian atmospheric sciences community. The question has been, has Martian climate changed significantly since the era of the Viking spacecraft missions in 1976? And as far as this investigation is concerned, the basic question is the atmospheric temperature in the interior of the Martian atmosphere cold today, or is it warm as it was at the time of the Viking spacecraft missions? And I would like to now show the profile that we found, which is the next figure. Thank you. I'd like to walk you through this profile, assuming I can get this cursor to work, starting at the very top, which is what is the part of the profile that Mars Pathfinder encountered first. Up here at about 120 kilometers down to about 60 kilometers, we find that the blue line, which represents the Pathfinder temperature profile, versus the red line, which is the Viking temperature profile, that the atmospheric temperatures are quite a bit colder than they were at the time of Viking. This is only for the upper atmosphere, however. What you might also notice is that there is this pronounced minimum here at approximately 80 kilometers, and that is the coldest temperature ever measured on Mars. It's a chilly minus 275 degrees Fahrenheit at approximately 80 kilometers altitude. As we now go further into the atmosphere, as Mars Pathfinder did, we reach below 60 kilometers altitude. We find that the temperature profile is actually very similar to the Viking profile. In other words, from about 60 kilometers down to about 13 kilometers altitude, the atmospheric temperatures on average are indeed as they were approximately during the Viking era. I'd also like to point out that there are features throughout this profile that are undulations in that temperature profile, and those are very interesting to meteorologists because they presumably represent some form of atmospheric wave, possibly solar tides, as were discussed.
Well, they've done it again. Wow, this reporter. Great new pictures of Mars. The most significant picture of the day's briefing, the little rover that could, roving its way over to a rock known to us all as Yogi Bear. Here's what that movie looked like. The scientists on the ground are using a camera back on Pathfinder to take these shots. We'll show them to you again and again and again. John Zarella, did you get a sneak preview at these shots, or were you watching them for the first time, same time I was? And what did you think?
I hadn't seen the movie. I saw the two still photos, this one and the one that looks like it's taken through a fisheye lens, which is the one that's taken off of the Sojourner rover. And I can tell you, we don't see it clearly in this video, John, but it actually runs over the rock named Boo Boo that we were telling you about, the small one right in the front of Yogi there that we can't really see too well in this picture. They've got several other names now: platypus, souffle, egg, chimp, hedgehog, and they have a little flat top as well. I went and checked the board today.
Yeah, still no
John?
Zarella. We got a color photograph made from some of the computer imagery for Mars. I've got it here on the anchor desk, John. And what we've done is taken our little rover model and put it about where it is on the surface of Mars with its spectrometer, its sniffer, up against the back of the rock Yogi. This is the rock Yogi. The rock Boo Boo, which John was just talking about, is kind of caught in the glare, but it's right there. Very dark rock, according to the people who were explaining these pictures to us a couple minutes ago. We need to let you know what we're going to be doing for you over the next couple days. Be another briefing, 3 o'clock Eastern time, roughly 22 hours and 3 minutes from right now. We'll be there for that live, as we always are. But tomorrow night, 10 o'clock Eastern time, 7 o'clock Pacific time, John Zarella and I will be here with a cast of dozens to replay for you every single picture we have seen from the surface of planet Mars in the past 8 days. It's going to be an hour-long special. This is the thing you ought to tape record for your children and your grandchildren, because it's going to be very good. And we're going to talk to the experts about what has happened so far, what is going to happen, and what it all means. Inside Politics coming up next. Thanks for being with us for this half hour. See you soon.